I found 3 methods of checking household batteries. The first method is the drop test. This is purely mechanical, it requires no equipment. Good batteries tend to drop with a thud. Bad batteries tend to bounce and sometimes fall over. You can see this is fairly imprecise, and unless you have a good and a bad battery for comparison, it's hard to interpret. The second method is the functional testing. I've used various things. This is a single cell electric trimmer taking a AA battery. That's a good battery. The bad battery. This is a single cell electric toothbrush that takes a AA battery. It's on. You can see that works well. With a bad battery, nothing. This is a good tester, but it only can test one size battery. Here we have a 1-cell AAA Coast flashlight, and notice how bright it is. It has a good battery in it. Here it is with a bad battery. Notice so that's an accurate test, but the battery has to be pretty dead. Here's a AA single cell flashlight, and notice how bright it is. And here it is with a bad battery, and notice that we get no lighting whatsoever. This is a D-cell 1-cell flashlight. Notice how good it is. And here it is with the bad battery. I modified this D-cell 1-cell flashlight so that I can test C batteries with it. And notice this battery is very good. The way I modified it was to basically fit a piece of cardboard around it so it stays centered. As you can see, this method requires more equipment than you'd like, and it would be better to do this with one device. But I found that the best method is to use electrical testers. First, I looked at the multimeter, and the multimeter only has one setting for household batteries, and that's 20. And when you test the 1.5 volt batteries, the really good ones give you more than 1.5 volts. The bad ones register below 1. The C batteries give you over 1.5, so that's good. The bad ones are for the 9-volt batteries. Gives you over 9, that's good. For the bad one, -1. For the AA's, they're going to be above 1.5. That was a little bit weak. And then the bad batteries, definitely below 1. The AA's, it's a good one. Bad one. Also works well for the 3-volt lithiums. There it's above 3. Bad one, it's 0.77. And for the button batteries, good one is 1.5. These are 1.5 volts. This one registers 0.3. So this device works pretty good. The problem with this device is it's a little bit more expensive. It only has the one setting, and it doesn't provide unique resistance for each battery. And the other thing is, it requires a battery itself. If you use it and forget to turn it off, when you go back to use it again, because it requires a battery, the battery may be dead. It takes a 9-volt battery. If the battery's good, and you can see that it's dead and in the replace range. When I was looking at the multimeters, I found that there's actually a specific battery tester. And you'll notice that this is a GB Instruments. It's the 500A. It costs $16.99. I bought it at Ace, and I had $5 reward, so I was able to get it for $11.99. It doesn't require a battery, and it has specific settings for each one of the batteries. The most common setting is the AA, C, and D battery setting, which is they're all 1.5 volts. And the reading on this is good, questionable, and replace. So these are the good ones. This is a good D. Notice it's in a good. This is a bad D. Notice that it doesn't register. This will do the C batteries as well. This is the good one. It registers in the good range. The bad one registers in the bad range. You'll have to change the setting to the 9 volts. Come way over here like this. The 9 volts. And you'll notice this one's good. And this one is bad. Now we have to change it to the AA's. For the AA's, it comes all the way around to here. And again, the good one and the bad one. Now for the AAA, which is 1.5 volts, the good one registers in the good, the bad one doesn't register. So I like this because it doesn't require a battery and it's easy to use. And we'll go over to the 3-volt lithiums. Good one, bad one. This is particularly helpful because there's a lot of 3-volt lithium battery devices. And finally, the button battery. So I just have to switch it up to the button cell. Check that again. Make sure you get the polarity right. This one's good. This one's bad. So this device provides the correct resistance for batteries like this. This device also provides a slot for the smaller batteries. This red here is usually positive, but actually you want to put the positive down here. And this is a good 3-volt. So we have to go to the 3-volt lithium and to test that, and you'll notice that it's good. It also works for the button batteries as well, but you have to switch it back to the button batteries. You can drop this in like this and check your button batteries, and you'll see that that's good as well. Gardner Bender also provides this cheaper model, which is a little awkward to use. You have to put the batteries in like this, and you notice that it tests good. You can also test the button and the 3-volt lithium batteries here. This is a pretty good device. I'm going to keep it in my tool drawer at the beach. I found that when I test batteries, rather than go to the multimeter, I go to the battery tester. It seems to be more universal and can test all the batteries, and it's fairly easy to change the settings which provide the proper resistance for each of the batteries. I hope this is helpful. Be sure to subscribe to my YouTube channel and give me a thumbs up. Press the bell next to the subscribe button, and you'll get my future videos. Thanks for watching.